Hello everybody, it is time to go over the lesson 1-3 worksheet, which is midpoint and distance. So we're going to start here with number 9. Number 9 is two parts. Part 1, it says point K is 1 over n of the way from J to L. What are the coordinates of K if n equals 4? So if n equals 4, that means that K is 1/4 of the way from J to L. And we learned how to do this in the notes. So if K is 1/4 of the way, what we're going to want to do is we're going to want to find 1/4 of the difference between the x coordinates, x2 minus x1, so 0 minus 4, and 1/4 of the difference between the y coordinates, -7 minus -5, y2 minus y1. So 0 minus 4 is -4, 1/4 of that is -1. -7 minus -5 is going to be -7 plus 5, which is -2. 1/4 of -2 is -0.5 or -1/2. Once we find those distances, we want to take that amount and add them to the x coordinates and to the y coordinates. So we're going to take that -1 and add it to the x coordinate of j, because it says from j to L. So we're going to take -4 plus, sorry, not -4, +4, plus -1. That'll be our x coordinate. Our y coordinate will be the y coordinate of j, -5, plus -0.5 or -0.5. And so when we put those together, we end up with 3, -5.5. And that'll be our answer. Still getting the hang of making these boxes. So then for B, it gets more interesting. What is the formula for the coordinates of K for any n? So for any fraction of the distance from point J to point L, we'll just take a look at what we did before and do that same thing but with symbols. So what we did, if we look backwards, is we took the x coordinate of J and we added 1/4 of the difference, and the y coordinate of J and the y coordinate of J, and then added 1/4 of the difference, like that. So what we need to do is write that out just with an n instead. We can say we start with the x coordinate of J, which is 4, plus that fraction, right? Because we added 1/4 of x2 minus x1. So we're going to write plus 1 over n, whatever fraction that would be, of x2 minus x1, which is 0 minus 4. And then for the y coordinate, we're going to do the same thing. We'll take the y coordinate of j, -5, plus, and then we'll take the difference of the y coordinates. So 1 over n times -7 minus -5. Right? And if we wanted to simplify that all the way out, it might look like 4 plus -4 over n, comma, -5 plus 2 over n. And you could take a look and figure out, how that would get there if you wanted to. Number 10, describe and correct the error a student made in finding the midpoint of CD with these 2 points. So when we find the midpoint formula, remember, we want x1 plus x2 over 2 and y1 plus y2 over 2. And of course here they didn't do that. They did x1 minus y1 and x2 minus y2. So they subtracted the coordinates instead of adding them. Boy, do I wish my handwriting was better. Okay, so then what it should be, because it says describe and correct the error, remember? So what we want to do here is instead it's going to be -4 plus -1 over 2, and then 5 plus -4 over 2. So when we do that, we'll get negative 5 over 2, or negative 5 halves. That's fine. And 5 plus negative 4, that's 1, so we got 1 half. So our new coordinate point is negative 5 halves, comma, 1 half. Number 12, suppose PQ has one endpoint at P is 0, 0. That's really nice because that's the origin. If 2, 5 is the midpoint of PQ, what are the coordinates of point Q? So if we start at P, which is 0, 0, and then 2, 5 is the midpoint, then all we really have to do is take the distance from 0, 0 to 2, 5 and double it. And since 0, 0 is the origin, then I know that from 0 to 2 is 2 units, so my point Q is going to be double that, or 4 units away from 0. And then my y-coordinates go from 0 to 5. We're going to double that and make that 10 units away from 0. So the coordinates of point Q are 4, 10. For B, how would you find Q if 2, 5 is 1/4 of the way from P to Q? All we need to do is the same thing, except for the fact that now we've got from 0, 0 to 2, 5, and that's only 1/4 of the distance. So what do we do with 1/4 of the distance? We're going to multiply it times 4. So we take our 2 and we multiply it by 4, so that's going to be 8. So from 0 to 8. And we take our 5 and we multiply that by 4, and so that's 20. So 820 is going to be the distance, point Q there. Then we've got number 15. So we want to find the coordinates of each given point on line AB. We want to find the point 3/10 of the way from A to B. So if we're doing 3/10 of the way, we have to find 3/10 of the difference between our x-coordinate and our y-coordinates. So when it says from A to B, that's really important because that means that we're going to take our B minus A to get our difference. So we'll take the x-coordinate of B, 12, minus the x-coordinate of A, negative 4, right? And that's positive 16. We want 3/10 of that. We want 3/10 of 16, and that's going to equal 4.8. Then we're going to do the same thing with the y-coordinates. We'll take the y-coordinate of B, 5, minus the y-coordinate of A, negative 7. Oops, we don't need that part. 5 minus negative 7, of course, is going to be 12. So then we do 3/10 of 12. So 3/10 times 12 is going to give us 3.6. And so now we take those new distances, right? We're adding 4.8 to the x-coordinate and 3.6 to the y-coordinate, and we add them right on to point A because we're going from A towards B. So we take negative 4 plus 4.8 for the x-coordinate, and we have negative 7 plus 3.6 for the y-coordinate. And so that final coordinate point then becomes 0.8, comma, negative 3.4. And that will be your answer. All right. Next, we've got to find the midpoint of PQ. We've got some fractions here. So we want to do some fraction work then because, hey, sometimes it's important to keep ourselves up to date on how to find fractions. So we know how to find the midpoints, right? Because we are just going to use the midpoint formula, x1 plus x2 over 2. So I've got 4 1/3 plus negative 2 1/5 over 2. I'm going to go ahead and I'm going to change those to improper fractions right away. So 4 1/3 becomes 13 thirds, right? Because that's going to be 12 thirds plus 1/3. And then we're going to add that to negative 2 1/5, which is going to become negative 11 fifths, because it's negative 10 fifths plus negative 1/5. And when we add fractions, right, we want to keep these in fraction form. So when we add fractions here, we're going to want to make these common denominators. So I'm going to make them into 15ths. So multiply by 5/5 on the left and multiply by 3/3 on the right. Remember how to do this? I end up with 13 times 5, right, which is going to be Give me a minute here. I have a calculator. I don't need a calculator. It's 65. 15ths plus negative 11 times 3 is negative 33 15ths, which is going to end up giving me 32 15ths. Right, so that's what I got when I added together 4 1/3 and negative 2 1/5. Now I need to take that divided by 2. So 32 15ths divided by 2, or times 1/2, is going to give me 32 over 30, or 16 over 15. That would be our x coordinate in our final answer. We'll circle that just for now. Then we also want to do it with our y coordinates. So we've got to add together our y coordinates and divide by 2. So we've got 3 1/6. Whoops, I wanted to change that one to a mixed number. Or not to a mixed number, to an improper fraction. So 3 1/6 is going to be the same thing as 19 over 6. And we're going to add 3 2/3. So 3 2/3 is the same thing as 11/3. And if we want to make this into a mixed number, not mixed number, I keep saying that. We want to make them into common denominators. I'm going to multiply by 2 over 2 on the right so that they both become sixths. It's going to be 19 sixths plus 22 sixths, which altogether is going to give us 41 sixths. Right, and I also need 41 sixths to be cut in half, right? Because I have y1 plus y2, need that to be divided by 2. So I'll take 41 sixths, divide by 2 is the same as multiplying by 1/2, not 1/12. Where's my eraser? 1/2. And that's going to give me 41 twelfths for the y coordinate. So my final answer after doing all this fraction work is 16 15ths, comma, 41 twelfths. Of course, you can definitely do that in a calculator as well, but sometimes it's interesting to brush up on our fractions. Then we've got Cameron, Arthur, and Jamie are playing soccer. Their locations are recorded by a motion tracking system. The distance between grids is 5 meters. The soccer ball is located at the points 35, 60. Who is closest to the soccer ball? So let's go ahead and mark 35, 60 on this graph. Right there. And we're going to have to use the distance formula for this one. So we've got 3 people. We've got Arthur, Jamie, and Cameron. So we'll start with Arthur. Maybe I'll go ahead and write in their distances on here. So Arthur is at 20, 35. Jamie is at 45, 20. Cameron is at 65, 40. And of course, the soccer ball is at 35, 60. So we'll go ahead and we'll start with Arthur. And we'll work on the distance formula. So of course, the distance formula is going to be the square root of x2 minus x1 squared. So we can go with 20 minus 35 squared. Let's make this bigger. And we'll add on y2 minus y1 squared. So plus 35 minus 60 squared. And then we got to go ahead and simplify that. So that's going to be the square root. Love that this changes my terrible squiggly lines into straight lines. The square root of 20 minus 35, that's going to be negative 15 squared plus 25 squared. That's going to give me the square root of 225 plus 625, which ends up being the square root of 850. And of course, we could find the actual number that is, but since we're just comparing distances, we don't really need it. All right, then we'll look at Jamie's distance from the ball. This is definitely a formula you should have memorized. So Jamie's got the same thing going on. I'm going to use the distance formula. x2 minus x1 squared. It's going to be 45 minus 35 squared plus y2 minus y1, and so that's going to be 20 minus 60 squared. So when we start to simplify that all, that's going to become 10 squared plus 40, actually negative 40 squared. And then that's going to give us 100 plus 1600, which gives us the square root ultimately of 1700. Then finally, we also need to find for Cameron. So here's Cameron's stats. He's got the square root of 65 minus 35 squared plus 40 minus 60 squared. And that's going to be then the square root of 30 squared plus 20 squared. And that gives us the square root of 900 plus 400, or finally the square root of 1300. So when we compare all those distances to the ball, of course, that means that Arthur is closest. Perfect. Next, a lighthouse casts a revolving beam of light as far as the pier. What is the area that the light covers? Ooh, this is a good problem. There's lots to this one. So first of all, it's a revolving beam of light. So if we think about what shape the light is going to make, right? If it revolves, goes as far as the pier, but it's revolving, it's going to make a circle. So when we find the area the light covers, we're going to need to find the area of a circle. In order to find the area of a circle, remember that it's going to be pi times the radius squared for the area. So we're going to need to find the radius. The radius in this case is just going to be the distance from the lighthouse to the pier. So we're going to go ahead and use the distance formula from the lighthouse to the pier. So we've got the square root of, well, the pier is at 2, 4, and the lighthouse is at 9, 7. So the square root of x2 minus x1 squared, so 9 minus 2 squared, plus y2 minus y1 squared, that's 7 minus 4 squared. And that's going to give us the square root of 7 squared plus 3 squared, which is going to, of course, be 49 plus 9, or the square root of 58. However, the radius is not the square root of 58 miles, because 1 unit on the graph is 0.4 miles. So to figure out how big this radius actually is, we can do the square root of 58, which is of course just a number, and multiply it by 0.4 miles. And that's going to give us a 3.04 mile radius. Once we find that radius, that would be the distance from the lighthouse to the pier, we can plug it into the area formula for a circle, pi times 3.4 squared. So that is going to give us pi times 9.24. So we could say our answer is 9.24 pi, because we like to leave things in terms of pi. But since this is a decimal, I think it's probably better to just call this 29.03, which is what we get if we do 9.24 times pi. Remember your units on here. We have area in miles, so that's going to be miles squared. And there is your final answer. Does it not? It didn't even recognize. It's supposed to be a rectangle notability. Please help me out here. There we go. Okay. And one more question. RS has endpoints at 6, -4, and length of 17, which cannot be the coordinates of S. This is an interesting question. So if it has endpoints at 6, -4, and length of 17, what we can do is we can find which of these endpoints, A, B, C, or D, create a 17 as the distance. If we use 14, 11, for example, and 6, -4 as our coordinates, does that give us the correct distance? That means we're going to have to use a lot of distance formula. So we've got, for A, I'm going to come down here, x2 minus x1 squared. So that's going to be 14 minus 6 squared plus y2 minus y1 squared. That's going to be -4 minus 11 squared. So that's going to be the square root of 8 squared plus -15 squared. That's going to be the square root of 17 squared, which is 17. So that would work. B, we've got the square root of 6 minus 6 squared plus -4 minus 13 squared, which is going to be the square root of 0 plus -17 squared, which is also 17. So B works. C is going to be the square root of 9 minus 6 squared and plus -12 minus -4 squared, which is going to give us the square root of -15 squared plus -8 squared. And I happen to know that 8 squared plus 15 squared is 17 squared. That's how I know that this is 17. That's just a math fact that I've learned from my teaching. And then that means that that can't be the answer because that also comes out to 17. So we'll try letter D. That's going to be the square root of 23 minus 6 squared plus 13 minus -4 squared. And that is going to give us the square root of 17 squared plus 17 squared. Hey, that's more than just 17. So this is not 17, which means D is the answer choice, which cannot be the coordinate of S. And we don't even need to try E then. So this was kind of a long one, lots of calculations here, but I hope that you are understanding well. Let me know if you've got any questions at all, and make sure that you are trying your hardest when you do these instead of just watching through the videos before you work on your assignment. Have a wonderful, awesome day.